Hello and Assalamualaikum. This is our group assignment presentation for TST0925 Physical and Organic Chemistry entitled Haloalkanes. Hello classmates, we are group 7. So these are our group members. First, Ahmad Faris bin Zularisam. Second, Muhammad Nur Ilman Fakri bin Muhammad Razmi. And third, Omar Abdul Aziz bin Jaya. Are you excited to know more about haloalkanes? Task 1. Synthesis and reactions of organic compounds. The instruction is compound B, C3H7Cn, can be formed from a haloalkane A, C3H7Br. Suggest the structure of haloalkane A and give its IUPAC name. State the classification of haloalkane A. Give the reagent and conditions necessary to form B from A. Next, state the type of mechanism for the reaction occurs and show the reaction mechanism. Compound B can undergo reduction and hydrolysis to form amine and carboxylic acid respectively. Draw and name the amine produced when compound B undergoes reduction with H2, platinum and heat. Next, draw and name the carboxylic acid produced when compound B undergoes hydrolysis with H2O and H+. Another haloalkane C is the isomer of A. Draw the structure of C. Show how C can be used to synthesize 2-methyl-3-hexanol and benzene 1,4-dicarboxylic acid respectively. The mark is 20 marks.
Okay, this is a structure of haloalkane A, as you can see in the figure below. The IUPAC name is bromopropane, more specifically 1-bromopropane, and the classification is primarily halide. Okay, for the formation of the compound B from haloalkane A, the haloalkane, which is bromopropane, react with the potassium cyanide in the presence of alcohol, more specifically is ethanol, and heat to produce a nitrile compound. The reagent and condition necessary to form B from haloalkane A is we use potassium cyanide, ethanol, and reflux. The reaction is nucleophilic substitution with potassium cyanide. The type of mechanism is by molecular nucleophilic substitution, SN2. The reaction mechanism, as you can see in the figure below. Don't forget to draw an arrow correctly. Rate which slow and fast, and last but not least, draw your structure in a 3D. Reduction of compound B to form amine. From the compound B, which is butanitrile, uh, undergoes reduction, react with the hydrogen, platinum, and heat, and it form butanamine. And then the hydrolysis of compound B to form a carboxylic acid. From a compound B, butanitrile, it undergoes a hydrolysis with water H2O and hydrogen ion to form a butanoic acid, as you can see in the figure. Okay, how compound C can be used to synthesize 2-methyl-3-hexanol? So as we can see, isomer of the compound A, which is isomer C, for haloalkane C, we choose the 2-bromopropane. So 2-bromopropane react with the magnesium and form the product. The product is the next step is the product react with the butanol, undergoes the hydrolysis with the water and hydrogen ion, and is formed a 2-methyl-3-hexanol. Okay, how compound C, which is 2-bromopropane, used to synthesize benzene 1,4-dicarboxylic acid. Compound C, 2-bromopropane, react with the benzene with the catalyst of aluminium to form a product with the hydrogen bromide. After that, the product react with the chloromethane with the aluminum chloride as the catalyst to form a product. Then the product react with the kalium manganate and hydrogen ion with heat to form a benzene 1,4-decarboxylic acid. Okay, for the task 2, example of inert component. Functional group present is haloalkanes. Chosen plant is olive and related Quranic verse Surah At-Tin 95/1. Bismillahirrahmanirrahim. Watini wa zaitun, and it is regarding the olive. Component present in olive. One of the component present in olive is carbon tetrachloride or olive oil, occurs naturally contained in olive plant. 4 chlorine atoms are positioned symmetrically or tetrahedral configuration, and it is covalent compound because it has 4 nonpolar covalent bonds between carbon and chlorine. It is mainly triglycerols, free fatty acids, phosphatides, flavor compounds, sterols, and microscopic bits of olive. It contains 30% carbon tetrachloride with 3 ml over 1 kilogram, water, lipids, and sugar content. Fat, saturated fat, zero carbohydrate, fibers and protein, 500 kilojoule food energy, vitamin E and vitamin K. Benefit of olive: an emulsifying agent and dissolve sufficiently to carbon tetrachloride to induce liver damage. No toxicity. Contain a large amount of antioxidants that are biologically active and may reduce the risk of chronic disease such as fatty inflammation. It can lower also blood pressures. For the chemical reaction, carbon tetrachloride can be synthesized by the reaction of methane and chlorine. For the reagents, methane gas and chlorine gas combine, and then the product is carbon tetrachloride and hydrogen chloride. Okay, that's all. Thank you for watching and good luck for your final exam and do the best. Inshallah, A plus chemistry.